welcome to the practice problems video for curvature. Okay, so for this question, we're supposed to evaluate the curvature of r of t, which is cosine t sine t t squared, at t equals pi over 2. Okay, so for any kind of curvature problem, what I like to do first is check to see if it's an arc length parameterization, first of all. If our given parameterization is an arc length one already, because then we can automatically just use the simple formula, which is the magnitude of the tangent of the unit tangent vector with respect to the arc length, which is s. But anyways, so let's check to see if that's true. So what we're going to check is the magnitude of r prime of t, does that equal 1 all the time? So this is the same as asking, is this an arc length parameterization? Okay, so let's calculate r prime of t. So that's going to be negative sine t, a positive cosine t, and a positive 2t. Okay, so let's find the magnitude of that. So we're going to square all of the components and then add them together and put a radical sign over the top. So that's going to be sine squared t plus cosine squared t plus 4t squared. Okay, and then square root here. Sine squared plus cosine squared turns into a 1. Right, so we're going to get 1 plus 4t squared under the square root, which is not equal to 1 for all t. It must be for all t. So if t is anything other than 0, then that wouldn't be true. So this is not an arc length parameterization, so we can't use that easy, simple formula, but instead we're going to use the alternative formula that says that curvature is the magnitude of the r prime of t crossed with r double prime, and then divided by the magnitude of r prime of t to the third power. Okay, so what we're going to do is find the second derivative, because we already found the first one, right? We already found the first one here. I'll copy it down on the next slide and we'll find the second derivative. Alright, so r prime of t is going to be, we found it to be negative sine t, a positive cosine t, and 2t. Okay, so now for the second derivative, we just derive once more. So we get negative cosine t, a negative sine t, and a 2. Okay, so now what we're going to do, actually before we cross these two, I want to just, because we're evaluating the curvature at t equals pi over 2. So what I'm going to do right now, just to make our lives easier, is plug in that pi over 2, so we can get actual numbers to work with instead of all these like variable terms. Okay, so r prime of t is now pi over 2. Let's plug that in and see what we get. So this is a negative sine pi over 2. And then we get cosine of pi over 2, and then 2 times pi over 2. Okay, so this simplifies to the following. So we have a negative sine pi over 2, so that'd be a negative 1. And then cosine pi over 2 is just 0. And these 2's cancel, so we just get pi. Okay, so this is our first one. That's r prime, evaluated at our t value of pi over 2. So now let's find the same thing, but now for the second derivative. So pi over 2, we're plugging that in for t. And now we have negative cosine pi over 2, negative sine pi over 2, and just a 2. That's still there. Okay, and then this is going to turn into, so cosine at pi over 2 is still 0, and negative sine pi over 2 is going to be a negative 1, and then at the end, oh no, sorry, yeah, and then we have a 2 at the end there. Okay, so now that we found these two, we can cross them and see what we get. So let's see, trying to see if I have enough room. I think I have enough room. So we're going to cross r prime of pi over 2 crossed with r double prime of evaluated at pi over 2. Okay, so this is going to be, we're going to set that up, I hat, j hat, and k hat. Okay, so the r prime stuff goes along the middle row here, so negative 1, 0, pi. And then we have a 0, a negative 1, and a 2. Okay, so this is going to be, if we have our I here, so we're going to circle that one first, and we draw our lines through. So this is going to be 0 minus a minus pi, so plus pi. Then we have our minus from the formula, minus j hat times what? Negative 2 minus a 0, okay? And then plus the k hat, which is going to be the last one. So negative, so that's going to be a positive 1 minus a 0. Okay, so another way to write this is just going to be a positive pi a positive 2, and a positive 1. Okay, so this is our the cross product that we got from crossing the r prime and r double prime, both evaluated at pi over 2. Okay, so we're going to keep this in mind, and now we can take the magnitude of it. Okay, so the magnitude of r prime of of pi over 2 crossed with r double prime evaluated at pi over 2 is going to be the magnitude of pi and then a 1, wait, hold on here, pi, comma, 2, there we go, 2 and a 1. Alright, so that's going to be, we're going to square each component separately and add them together, okay, and then put a square root symbol. So this is going to be equal to pi squared plus 5 under the square root sign. Okay, so this is going to be the top portion of our curvature answer, basically. And now for the bottom portion, all we have to do is find this following thing. Okay, so we're going to take whatever we got for our r prime evaluated at pi over 2. We're going to take the magnitude and then we're going to raise it to the third power. Okay, so this is going to be equal to, so the magnitude, or the vector that we obtained was negative 1, 0, and pi. Okay, so we're going to take the magnitude of that and then we're going to raise it to the third power. So to take the magnitude, we square each component, right? Plus 0 squared plus pi squared, square root it, and then we have this 3 on the outside as an exponent. Okay, so this is going to be 1 plus pi squared, and then we have square rooted, but then to the third power. So another way we could write that is just as, I'm going to switch it around. So pi squared plus 1, and we'll combine those and write 3 over 2 as the power. Okay, so this is the bottom half. Here's our top half. So our curvature evaluated at pi over 2 is going to end up being the square root of pi squared plus 5 over the quantity pi squared plus 1, quantity to the 3/2 power on the bottom. Okay, so that's all for that question we just solved for the curvature.